Hope every one of you are fine. It's a very critical time in your life. The complete country, the entire country is under lockdown. So you can utilize this time for your upcoming studies. Okay, so don't waste your time. Okay, utilize whatever resources you can find. So this is the fifth part of our video, class 10, Cbse Science, chapter 1. So here in this part we are going to study the last kind of reaction, the last type of reactions. We have seen different types of reaction. We have started from combination reaction, then comes decomposition reaction, the displacement reaction, then double displacement reaction, and now it is the time for oxidation and reduction reaction. So first of all, I will give you a brief idea what is the meaning of oxidation and what is the meaning of reduction. Okay. Oxidation and reduction are exact opposite process. Just like combination and decomposition, oxidation and reduction are exact opposite. So there are several definitions for oxidation and reduction. Okay, and the classical definition is the classical definition for oxidation is addition of oxygen. If we add oxygen to any chemical species, and we can say it undergoes oxidation. Okay. And on the other hand, if we remove oxygen, it is called reduction. Okay, so the addition of oxygen is called oxidation and removal of oxygen is called reduction. So what is the first definition? Addition of oxygen is oxidation and removal of oxygen is reduction. Now comes the second one, second definition. Okay, removal of hydrogen is oxidation and addition of hydrogen is reduction. Okay, this is the second definition of oxidation. Now the third definition, addition of an electronegative element is called oxidation and removal of an electronegative element is called reduction. So what do you mean by electronegative element? An element which has higher tendency to accept electrons are called electronegative elements. The most electronegative element is fluorine, then comes oxygen, then comes nitrogen, and finally it comes chlorine. Okay, these are the very highly electronegative elements. And the last definition, okay, it is the electrochemical definition of oxidation. Removal of electrons is called oxidation and addition of electrons is called reduction. Okay, so these are the definitions. So here in this chapter and for you in your syllabus, you need to concentrate mainly on the first two definitions. Okay, which are they? Addition of oxygen is oxidation, removal of oxygen is reduction. On the same, okay, in the next one, what is that? Yeah, addition of hydrogen is reduction and removal of hydrogen is oxidation. Okay, that's all. Now, you can see an activity there. Heat a china dish containing about 1 gram copper powder. What we are doing, we know copper powder is somewhat brownish, shiny brownish in color, and what we are doing, we are heating that copper powder in a china dish. What do you observe? We can see a brown colored coating appearing on the surface of this copper powder. Means after some time, after heating, the entire brownish, golden brownish copper color will become very dark brown color. So what is happening? Actually, while heating, what happens is the oxygen present in the atmosphere will react with copper and it will become copper oxide, which is black in color. Okay, and this copper oxide will coat on the surface of copper metal and which will give a black appearance, a black colored appearance. And you can see the corresponding chemical equation for that. Yeah, what is that? 2Cu. Okay, copper is reacting with oxygen in presence of heat to form copper oxide, and it is for balancing they have given the coefficients too. Okay, and if we pass hydrogen gas, into that copper oxide powder, we can get back the copper metal. Okay, and you can see the reaction. What is happening when hydrogen is reacting with copper oxide? This hydrogen will take away that oxygen and it will become hydrogen oxide or water. Okay, and what will be remaining? Yeah, we will be remain with, yes, exactly, copper. We will be, yeah, what will be what finally we will be having? Finally we will be having the copper powder. So when oxygen is added to copper, it is called oxidation of copper. Okay, when oxygen is added to copper, it is called oxidation of copper. Okay, and in the second reaction, it is oxidation. And the second reaction, when hydrogen is added to copper oxide, we can say copper oxide undergoes reduction. Okay, please don't ever write it is copper is getting reduced. No, copper oxide is getting reduced. Okay, copper is getting oxidized and copper oxide is getting reduced. Okay, that's the thing you need to remember. Okay, so if a substance gains oxygen during reaction, it is said to be oxidized. It is clearly given there. And if a substance loses oxygen during a reaction, it is said to be reduced. Okay, and check out this reaction. Yeah. Okay, when copper oxide is treated with hydrogen, you can see copper oxide loses oxygen to become copper. Means copper oxide lose oxygen means copper oxide get reduced, right? Am I correct? Yes. And now look at the second part of the equation. Hydrogen got oxygen and converted to water. Means oxygen is added to hydrogen, which means hydrogen got oxidized. Okay, so in this reaction we can see one reactant is getting reduced and the other one is getting oxidized. Okay, is it clear for you? Okay, I will tell you once more. Oxygen is coming out of CuO, means it is reduced. Okay, and that oxygen is added to H2, means H2 get oxidized. Okay, that's all. And we can find some more examples of this oxidation reduction couple. Okay, look at the reaction. ZnO plus C gives Zn plus CO. Yeah, what is happening? Zinc oxide is treated with coke or carbon. Okay, and while that chemical reaction, what is happening? Zinc oxide is giving oxygen to carbon. Means zinc oxide is losing electron, means it is undergoing reduction. And carbon is getting oxygen, means it is undergoing oxidation. So here carbon is oxidized and zinc oxide is reduced. Now second one, MnO2 plus 4HCl gives MnCl2 plus 2H2O plus Cl2. Yeah. Now it's a very bit more complex in fact. Okay. So first of all, what you have to do? Okay, you can see manganese dioxide lose oxygen, means it got reduced, and HCl got this oxygen and converted to H2O, means exactly HCl got oxidized. Don't be confused, don't be get fooled. Okay, it's simply nothing. MnO2 reduced and HCl oxidized. Here it is not H2 is getting oxidized, it is HCl is getting oxidized. I think it is clear now for you. Okay, and you can see from examples we can say that if a substance gains oxygen or loses hydrogen during a reaction, it is oxidized. If a substance loses oxygen or gains hydrogen during a reaction, it is reduced. That's all. Okay, and sometimes they might be asking you, find out which substance oxidized, which substance reduced, which is the oxidizing agent, which is the reducing agent. Okay, I will give you a clear idea about that. Again, consider this particular chemical reaction. Okay, here you can see CuO, what happened? Oxidized. Sorry, CuO, what happened to CuO? Yeah, CuO is reduced, right? CuO is reduced, H2O is oxidized. Okay, and the substance which undergoes reduction is called oxidizing agent, and the substance which undergoes oxidation is called reducing agent. It is a really simple thing. Okay, first of all you need to check out which substance gains or loses oxygen, okay, to find out which undergoes oxidation and which one is getting undergoes reduction in fact. Okay, so the substance which undergoes oxidation is called reducing agent, and the substance which undergoes reduction is called oxidizing agent. Okay, practice bit more, finally you will get it. Look at this, look at this example. Okay, you can see zinc oxide is undergoing reduction, means it is an oxidizing agent, and coke is getting oxidized, it is a reducing agent. So what is the meaning of oxidizing agent? Yeah, a substance which is capable of giving oxygen. You can see ZNO is giving oxygen to carbon. So the substance which is capable of giving oxygen is called oxidizing agent, and the substance which is helping other to get reduced, it is called reducing agent. You can see carbon is helping ZNO to lose its oxygen. Okay, so practice more, you can see several examples like this. Okay, on collect whatever number of chemical equations you can, and just try it out. Okay, try to find out which is the oxidizing agent, which is the reducing agent, which substance undergoes oxidation and which substance undergoes reduction. Okay, now you can see the application of this, or you can see the occurrence of oxidation in your daily life. Okay, and simplest of such experiences, such observation, first of all is corrosion. We can see metal articles, the articles which is made up of metal is getting tarnished when it is exposed to atmosphere. For example, you can see a brown colored coating on iron articles. We used to say it is a rusting of iron, the rust in fact. Okay, RUST, it is not REST, it is rust, RUST. What is happening? The surface of the iron, means the iron atoms present on the surface of the iron article is reacting with atmospheric water vapor and carbon dioxide. So whenever a metal is exposed to outer atmosphere, okay, the gases present in the atmosphere like oxygen, carbon dioxide, and chemicals like water or some acids or some bases, whatever it is. Okay, so the slow destruction of a metal, when it is exposed to outer environment, when it is exposed to something, it can be gases, it can be water vapor, it can be any other chemicals, it can be acid or whatever it is. So that slow destruction of a metal is called corrosion. It is called corrosion. Okay, we can see rusting of iron. Okay, the most common example is the rusting of iron. Then you can see the blackening of silver articles. Okay, you can see silver chains or silver articles, anklets, amulets, whatever it is. Okay, so after some time you can see a blackish coating appear on the surface of the silver article. It is because of the reaction of silver with atmospheric sulfur in fact. Okay, it is silver sulfate. Then a greenish coating appear on copper articles. So it is called basic copper carbonate. Okay, basic copper carbonate. And every year, because of this corrosion, a lot of things are getting destructed. A huge amount of sum is getting lost. Okay, in the entire world, millions of rupees. Okay, millions of dollars. In fact, millions of means tons of crores of rupees and articles are getting wasted every year because of this corrosion. Okay, and the second one you can see rancidity. Okay, what is rancidity? Rancidity nothing else. Okay, oil fried food edibles. Okay, oil fried food articles, foodstuffs. when it is kept for longer days, okay, when we are opening it for after a long time, you can get an unpleasant smell from that stuff. Okay, it is because the oil present in the, for example, we are having some potato chips or something, it is Lay's or Kurkure, whatever it is, okay, potato chips or homemade potato fries, whatever it is, okay. So what is happening? The oil present in these chips will react with atmospheric oxygen, okay, and which will give out that unpleasant kind of chemical, having that really disturbing odor, okay. So, and you can see it is called rancidity, okay, it is called rancidity, and you can see Lay's packets, okay, you can see the packets of Lay's, okay, it seems to be pretty huge, right, okay, and in fact it is having only 2 or 3 chips, and you can see it is flushed with air. And you might be thinking, what is the need of this thing? What is the need of why they are giving this much bigger packet and only 5 or 6 chips? Actually, what they are doing is they are preventing this rancidity. They are preventing this rancidity by flushing in nitrogen gas. Okay, so it is a very important thing. Okay, prevention of rancidity, okay, prevention of corrosion you will study in other chapter. It is called metals and non-metals. Okay, in that chapter you will study about prevention of corrosion, how we can prevent corrosion. You can see something, painting of iron articles, greasing of things, oiling of things, okay, those kind of things. Okay, you will study those things in detail in metals and non-metals. Now here our focusing point is rancidity, how we can prevent rancidity. Okay, so whenever they are packing these chips, they will be flushing this packet with nitrogen. And what is the significance of flushing with nitrogen? So always remember, nitrogen is a very less reactive gas, very least reactive. It's quite inert at room temperature, it will not react at room temperature. And when we are flushing this chips packet with nitrogen, okay, suppose oxygen is coming to react with this chips, okay, and what is present there? There is a coating of nitrogen is there, right? And this nitrogen will save the foodstuff from reacting with oxygen, so that they are flushing chips packet with nitrogen. Okay, now we can see the questions. Really simple things. Why does the color of copper sulfate solution change when an iron nail is dipped in it? We have seen the activity, and what is happening? Yeah, because iron is more reactive compared to copper, iron will displace copper from copper sulfate solution. So instead of copper sulfate, what will form? Iron sulfate will form. So that is because the color is changing. Give an example of a double displacement reaction other than the one given in activity 1.10. Okay, one more example of double displacement reaction. You can find some examples from this textbook. I will give you a quite simple one. For example, when sodium chloride is reacting with silver nitrate. Sodium chloride is reacting with silver nitrate. We will get sodium nitrate and an insoluble precipitate of silver chloride. You can see the exchange of ions. Initially, chlorine was with sodium and nitrate with silver. After the reaction, chlorine goes to silver and nitrate goes to NaCl. This is one more example. You can find several examples from this same textbook and same chapter. Identify the substances that are oxidized and the substances are reduced in the following reaction. Look, you can see, yeah, sodium. Sodium is reacting with oxygen to form sodium oxide. It is pretty clear. You can see sodium is added to, oxygen is added to sodium, means sodium get oxidized. Sodium get oxidized. Okay, and you can see oxygen atoms lost from O2 molecule, right? Okay, O2 molecule actually it is O2 molecule is split into oxygen atoms. So O2 molecule lost its oxygen is somewhat confusing for you. It's nothing. If one substance is oxidizing, the other should be reducing, right? Okay, so when sodium is getting oxidized, what is getting reduced? Yeah, O2 is getting reduced. Okay, now second one, CuO plus H2 gives Cu plus H2. We have seen the example before. Yeah, CuO plus H2 means C. Okay, look at what happened after the reaction. CuO becomes Cu, means it lost oxygen, means CuO get reduced. H2 becomes H2O, means it got oxygen, means H2 get oxidized. That's all. Okay, I think this area is clear. So we came to the end of this chapter. That's all about the chapter. So try to watch all these videos from part 1 to part 5. If any doubts arising, okay, please free to comment. Be free to comment all this stuff on the comment box. So try to make some notes, study well. If you are not understanding any concept, okay, try to hear it once more. You can ask me freely any doubts. So we can see with the next video would be solving the exercises. Okay, next video would be solving the exercises. So until then, bye guys.